All right, hi everyone. So I'm only here to tell you that Neo4j is awesome, and you should use it, and get into it. That's it, thank you. So, like Code Rabbi, who is a really awesome person, said, learn the most by sharing your knowledge with others. So here we are, whee, let's get started. So this talk is entry level, which means I assume you have 0 graph database knowledge. I do assume you have some relational database knowledge. But if you don't, you will still get something out of this talk, and most of it don't require it at all. And this talk is also uniquely open source. So if you think there's something to add to something I say, or if you have a question, just feel free to let someone run with a mic, I guess. So in case you still get nothing out of this talk, here's a picture of me with a dragon that my mom made. Obviously, it's me using Java on that laptop. The dragon is peaceful. So I know some of you are going to wonder entire talk about my accent, so I may as well tell you so that you can focus on the talk. I'm originally from Sweden. I'm half Danish, and I lived in the Netherlands for 6 years, and now 5 years in Switzerland. So my accent is European. If you at any time don't understand me, or I'm too quiet or anything, let me know and I'll repeat. I work at Leap. It's awesome. At Leap we do a lot of things, actually not graph databases, but my main job as a graph database expert at Leap is explaining why GraphQL is not a graph database. So I'm a data nerd, which means I work with data. I collect it, I analyze it, I hate it and I love it, and I use a lot of different databases. So there's a lot of different databases for a lot of different things. And Neo4j is just one of them. Neo4j is just one out of many graph databases. So let's talk about you. How many here use relational databases often? Okay. And any here have an experience with graph databases? Okay, the 3 of you is not going to get much out of this talk. Any of you have anything? Have you used Neo4j? Okay, great. And who has green as a favorite color? Okay, you're going to love my slides. So Neo4j is an open source graph database from Sweden. And that's why I'm proud I'm Swedish, because one of my favorite technologies is from there. It has 2 editions. The community edition, it's a fully functional edition of Neo4j. It's suitable for single instance deployments. And you can play with it, and it's free, and it's awesome, and it's open source. But if you want to scale your database, you're going to need Enterprise Edition. So it includes key features for performance and scaling, clustering, online backup functionality, and all the things you need if you want to run Neo4j on production. But for playing with it, ignore this. There's meetups everywhere if you get really into this after my talk. Literally everywhere. So go to neo4j.meetup.com and you'll find them. So graph theory was first invented by Leonard Euler with his bridges in 1736. So he wanted to figure out how he could go for a walk in this town with 7 bridges and 4 islands. Could he go for a walk without crossing one of the bridges twice? And it was quite hard for him to calculate without trying to walk and draw on the map. He wanted to find a mathematical solution for his problem to see if he could walk to all islands, crossing each bridge only once. So first he simplified by drawing a picture of bridges, and he removed the city and all the noise so he could really look at the problem. And then he made the first world's graph. He drew the 4 islands and the connections between them, the bridges as we speak. And in this graph, you can move the islands wherever you want because they're still connected. And in this graph, we see the dots and lines, the nodes and edges. And we can see that each island has 3 bridges, 3 relations. And we can easily, just with an overview, look at this problem. And we can count and we can see how many times you cross the lines. And it's an easy way to visualize a mathematical problem. And then when you go from node to node, you traverse it and you see, yeah, it is indeed impossible to cross the bridges only once. So graph is data that is connected. That's all there is to it. And graphs are everywhere, literally everywhere. And you might recognize some of the logos on this picture. These are just some companies that use it in production, but there's lots more. It's modern. The Facebook Open Graph is a very popular one. And using graphs to connect people, to have this who knows who likes what, it's a really powerful way to use graphs in social networking, which is really difficult to model in a relational database. So let's look at it a little bit more. A graph is an easy way to visualize connected data. So Michelle likes graphs. And in a graph, you have a node. The simplest possible graph is a single node. It doesn't have to have any relationships at all to be a graph. And a node can have properties, as many properties as you want. So you can say this is node York. And then you can have properties, country, UK, and everything you want. Or recipe, title, spaghetti bolognese. And obviously, a graph would be very, very boring without relationships. It would just be dots without any connections. So you can have as many relationships as you want. So what you may notice here, what I have done is that I'm teaching the syntax of Cipher on my slides, secretly. So here you see parentheses. And properties is in curly braces. And relationships is in square brackets, but I go more into that. So to figure out which nodes belong to each other, so which nodes are users, which nodes are recipes, which are ingredients, you can label them. And when you have a label, you can use that for easy lookup. Speaking of easy lookup, you can also, just like you can in a relational database, put an index on your properties. So if I often query people by name, I probably want an index on the name property of people, because it will be faster that way. There's also some constraints, so I can say that so-and-so should be unique. For instance, if in my case I have an ingredient, I cannot create another ingredient with the same name. So if you have constraints and indexes, it becomes kind of like an optional schema, which is really, really powerful. And here's one of my favorite graphs. It's just really beautiful. When you have graphs, you see a pattern. And with this pattern, without really thinking about it, without having to use any algorithms, you can look at the graph and you can say, okay, in the Wagner graph, I see that there is one person in the middle who has all these connections. Everyone knows this person or this thing. What is this? And yeah, it's a nice way to see patterns in your data. And also you can make art out of your database. It's really beautiful. Don't do that, or do, I don't know. So let's talk about graphs versus relational data. If you have a relational database, a typical question you could ask is, get all recipes for this user. And you could have a recipe table, and you get them, and it's fast. It's good. And then a graph question could be something like, what recipe should we recommend the user to cook next? What ingredients do they like? Which ones don't they like? We can find out these things much easier. Show you how. So relational databases have tables, as you know, and tables, these recipes to groups, have to be connected in some way. We want to know these recipes are in these groups. So that causes a join table, a query via the table, and this is how typically it would look like in a relational database. And this works, but it's not really visualizing my data in a good way. I think it's visualizing my data in a computer way, not how I would do it. If I look at my data and I draw it on paper, it would look like a graph. So imagine having actual relationships between your data, right? So you have spaghetti bolognese, who's in the pasta group, and in the Italian group. This is how your data looks like, rather than having to have data in a table that is not actually tabular data. So I really love how Neo4j is a better way to visualize data. How I can go on a whiteboard and actually make my whiteboard come alive. It's cool. So this is typically all the tables I would have in a relational database with some data, and you just look at it, you try to get an overview. And you see, okay, there's recipes, there's one spaghetti bolognese, recipe to group, and you try to put this data together, and you have to look over and over to see where it belongs, and it's confusing. But we simplify. This is the same data in a graph. You can just look at it, have an overview, be done. Yay! So, in a world of graph databases, performance is, of course, really, really important. If you have a relational database with a lot of join queries, it's going to be slow. The more number of relationships you have, the slower it gets, and the more tedious it becomes. But in Neo4j, the corresponding action is performed as navigation from one node to another, which means the performance is linear. And it's really, really good performance. You can have up to 4 million nodes on one core without sacrificing performance. And I don't know who wants to do 4 million relationships in a standard data set, right? So it's really, really, 4 million hops per second in core. I already said it's whiteboard friendly. Schema optional model is really, really useful. So relational databases, they do have a structure, but Neo4j has an optional structure. which is one of those really important things. So let's look at this popular e-commerce framework that I won't mention by name. They have this EAV model. So they are trying to have a flexible schema in a relational database. If you try to put something flexible in a relational database, you can't put the query on one slide. Join on. I have no clue what's going on here. So flexibility in a structured database costs a lot. It's really expensive. Don't do it. Every problem has a tool. Choose the right tool for the right job. So let's look at OmNomHub, the project that got me into graph databases. I really love cooking, more so than doing this pet project, apparently. But the idea with this project is that you can fork a recipe. And I really liked Paneer, GitHub fork recipe. So this means that you can change the recipe, but still keep track of where the original comes from. And this is something that I often miss on recipe websites, because you see a recipe and you wonder, is there some other version of this recipe? Where does it come from? Where does it originate? And if you can go back in history and you see all these changes, and you see also maybe the one person makes every recipe vegan if you're vegan, and you can have these really cool relationships. And obviously send change requests. I couldn't find any cool geeky wording for this that would be a cooking pun. So if anyone thinks of some pull request cooking pun, let me know. And you can join groups and share recipe collections among them. And have your own private recipe collections. But the part where graph database shines is that you can search for similar recipes. And you can do some other cool stuff, which I will get into. So the Neo4j Architecture. Here it is. It's the world's leading graph database, and it is built from the ground up as a graph database. It means that the architecture is optimized for fast management, storing, and traversal of nodes. It is fast. These are the three main points. The core API is where everything is. The traversal API is what tells you what you should look at next. And then the Cipher, it's like SQL for graph databases. So let's look at Cipher. Cipher has a really nice syntax. And it's, for me, pretty straightforward, but it might not be to everyone. So parentheses means nodes or hugs. Curly braces means properties. Square brackets means relationships. So we have the browser, which makes it really easy to visualize and query the data. So let's live dangerously and do a demo. So, an error occurred. So in Neo4j you have a thing called Neo4j Desktop. If you want to use it, you download that, and it's pretty straightforward from there on. They try to make it really easy for anyone to use and get started. So with Neo4j Desktop, you can't see my screen. This. Maybe it will be easier to explain if you can see my screen. So this is Neo4j desktop. And here you see that we have the recipe graph, and we can see logs for it and things that I've done in the past hour in settings and plugins. You upgrade it here, and you do everything in here. It's pretty cool. And then, like I told you, there's this browser. So you open the browser, and in here there's all the information that you can possibly need to write your queries, to look at your graphs, to change things in a really nice visualized way. So what I will do here is something you should never do in production. I delete all the data. So let's do that. And then we can start. Does everyone see, can everyone read this clearly? Is it too small? It's good. Okay. So here, we're creating one user. So we use the keyword create, and then we see again the parentheses, which means a node. So everything inside those parentheses is defining the node. So here, node is just a variable, so it could be called anything. And then we define a label, which is user. And as I said, curly braces is properties. So everything inside the curly braces defines the property. So here I say I want a property called name with the value Michelle. And then we return it. So let's do that. And we have our first graph, which is a single node. And what we see here in browser is that we indeed have the label user. And I don't like that color. That's better. And here we can change things, and we can look at it in different ways and really visualize our data nicely. So a graph would be pretty boring if I was the only person in it. So let's create a second person, Very Haximus, who was the person who started OmNomHub together with me briefly. And his real name is Dutch and really hard to pronounce. Very Haximus is actually easier. So let's create a second user in exactly the same way. And here, as I said, it's just a variable, so we could call it literally anything. So here's a second user, Very Haximus. And now it starts to be a little bit interesting adding relations. So then we use the keyword match, which is like the SQL select. So we match me. Again, that's just a variable. We can use anything. And we want to match a user label, which has the property name with the value Michelle. So again, the property is in curly braces, and the node we want to match is in parentheses. So then we say we also want to match friend with the label user, name Very Haximus. So then we have these two variables, me and friend. And we can use this variable to do anything with those two matches, right? So then we create a relationship. And the parentheses, they represent a node. So we create me, and then the square brackets is a relationship. and we call this relationship friend of. And then we say friend of friend. We're Haximus, and we return both of us. And what we will then see is the two nodes with a created relationship. So it would be pretty boring to be friends with everyone. No, maybe that would be fun. But for the purpose of data, that would be very boring. So let's create a user who is not a friend, but a friend of Buri. And you can see here in this query that I did not have a return. So it just shows us what we did. Most likely for these queries, we don't need to return anything. So we can also limit our data just like we can in MySQL. This will return all users, max 25. And here we see the relationships. And let's start creating recipes. Is the syntax clear to everyone now? Great, so let's go through this a bit quicker. Create recipes. And then we add a relation to this recipe. I made it. So again, it's a match query, me, and then we match the recipe as well. And here we decide to have a timestamp on this property. And this is the first time I gave this talk. Wow. So we create me with a relationship to the recipe, and we return it, and ta-da. And down here we can see the timestamp property. And we'll just go through this one. And if we want to get all the recipes of my friends, we can also match on a relationship. That's what you mostly do in graph databases and Neo4j. So you use the square bracket syntax to match a node with a relationship with another node. And then with another relationship with this node. So let's look at that. So now we saw that we match a lot on name of the user, and to speed this up a little bit, we create an index, and we do that with this syntax, create index on user, which is the label, and on that label we want an index on the property name. Now it starts to get quite interesting. So if we want to get all the friends of friends recipes, we need to match me again. And then we have this syntax. Times 2. It says how far we want to traverse in the graph. We can go on forever, or we can say just a little bit. And then we say, we're not me, friend of friend. No changes, because I probably forgot to create this. There you go. So here you can see that there's 2 recipes of my friends of friends, and I have no relation to them. So we also have a REST interface, which we can use to query our data in any application, be it PHP or Python or whatever you want. And this is the way you would query your data. So we see here that Michelle has ID 39. And you can see all the data that you get returned as JSON, and you can do anything you want with this data, which is really handy. And you can get a property. Or a specific property if you want. So this is just the API, but this is not typically how you would use it in PHP. So NeoStore is the way Neo4j stores data. It has several different store files, which makes it really fast. So each store has specific data, and they have a fixed data size. And fixed size means that it's really fast. And relationships have 33 bytes. There's not many types of properties you can have, but still, indexes, strings, and arrays makes this data come together. And hardware matters a lot. You're not going to get very far without much memory. Caching happens in memory. If you run out of it, it starts caching in the file system, and it starts getting really, 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 really slow. So let's look at what we want to do with OmNomHub in the future, in a land far, far away where I work on it. So you can connect users. So you both like this thing, and you can get connected. And you can connect recipes. These things have similar ingredients because you query by ingredients, and then you find all the recipes. And of course, in today's world, we like to be smart. Really smart. But I think the future of the web and where we're heading everywhere is what we really, really want to do with all our data and all the data we're collecting. We want to be creepy. So if you don't like something, we know you don't like it because you fork the recipes and you remove that ingredient. And we can see the relations between every ingredient you remove. And therefore we know, okay, this person either doesn't like this ingredient or they're allergic. And we can start making our own conclusions, and our recommendations is therefore much better. So, Neo4j in PHP. Of course, you can use the REST interface, which PHP does really, really well, as you saw. There's also the graph-aware PHP client. So here is a typical how we would use this client. So we create the client, we add a connection, and here we use a protocol called Bolt. So we then can use our Cipher query, which we can test in the browser and write our queries. And we get the result and run the query, and it's beautiful. And I had these slides too. So GraphAware also released an OGM, Object Graph mapper instead of an RM. How many people in here use doctrine? Cool, almost everyone. That's nice, because then you will recognize this. This is an entity. And it works just like doctrine. So you define that this is the ID, and at this an integer in here becomes the... I'm missing a slide now. So in between you see the property type string. In here we can define the relationship type forward, direction outgoing. And then we can target it to the user and say that it's part of a collection. I'll show you some code to make it easier to follow. But what we can do with the OGM is that we can find an entity and use the entity any way we want, which makes it much more straightforward than using Cipher. If you have simple data, this works great. If you have very complex data with a lot of relationships, it can sometimes get a little bit slow, so you want to see where you write Cipher queries and where you don't. It's a bit of an experiment with this OGM, but I really like it so far. Neo4j plus PHP is really well documented. So, graphs are everywhere to make it easy to visualize complex data. They make it easier to be creepily smart. And there are lots of resources out there. What I also want to show you is what you can do with graph databases is that you can create an API out of it. So if we go to Neo4j desktop again, and then I mirror my screen again. We see these plugins, and by default we have the GraphQL plugin. How many people in here use GraphQL? 2 people. Cool. So GraphQL is a nice API where you can query things. And you install it, and then you have a GraphQL client, like this one. And you can query it in any way you do GraphQL. But this is not a GraphQL talk. I just wanted to show you that it's really easy and straightforward to turn your graph database into an API with just 2 clicks. And here in the browser, is everything you need to start learning Neo4j, everything you need to start having fun, to start playing. It really goes through step by step, probably better than I did just now, how graph databases work. And it has literally everything you need. So download Neo4j desktop, play around, have fun, and yeah. Thank you. So I can show you more code, how to implement the graph databases, and we can also discuss different use cases. So it's up to you where the rest of this talk goes. Questions, input, discussions?
Is there a tool to actually take data from a relational database and put it into Neo4j? Is that the project, or do you have to do that manually?
So is there a tool to take data and put it into Neo4j? Yes. So you can use Neo4j desktop to import you can use Neo4j desktop to import data, so it supports different formats, such as CSV and other formats, and you can take data from anywhere and put it in Neo4j desktop, import it, and you have it as a graph. And there has been some really cool open data sets made with this. If you want a graph of all the Belgian beers, there is one. So, anything else you want to know? Cool. So, let's... How many people in here use Symphony? Great. So then you're familiar with a controller in Symphony, and I want to show you how straightforward this is. Here we go. So here we have a standard Symphony controller. And without the wiring, we don't have to have any config or anything. We install GraphAware Neo4j, Composer install, and we inject the client interface and entity manager interface, and it magically knows we need them. And then here for you, I have two ways of listing recipes. So we can either do it by a Cipher query, which is this way, and then we get all the records, and we lip through them, and return a JSON response with recipes. Or we can do the OGM action, which means we get the repository and we find by, which I think is a much nicer piece of code. So, I wanted to tell you that you are awesome. How would you use graph databases? No one knows how to use graph databases. I failed this talk. So some use cases that I had was an insurance company. They wanted to know how often people get sick. If they have these symptoms, how likely are they to not die, because that's pretty cheap, but to have a long-term disease? How likely will this insurance company have to keep paying? And by putting relations to symptoms and diseases and different people, they can calculate pretty well if you're expensive or not. It's creepy. But a less creepy way to use graph databases is by using flight tracker, for instance. So you can track your flights in a really nice way this way. Yeah.
I use it for static analysis. So basically, which is script can be turned into an AST, which is we like graph. And then when you just link the methods with the definition and the way they call each other, it turns out a graph. Very
Cool. So for the recording, he uses it for static analysis. It's also quite often used as, in social media, social platforms. And one thing that I I'm trying to convince my work to use it for. We have this huge API for the biggest retailer of Switzerland, and it's currently using Elasticsearch and MySQL. And in Elasticsearch, how many here used Elasticsearch? A few. In Elasticsearch, you have JSON documents stored in the database. And every time you change something, let's say we have products like we do in our products. Then if you have products and you have a label on each product, if you change one label, you have to go through every document on every product and change that label to reindex. And if you have millions of products like we do, changing that label takes a while. And you want to have these connections in a more straightforward way. So you would use Neo4j to have this label, change it there, and it's automatically updated everywhere. The problem with this, however, is that you don't have the full power of full-text search that Elasticsearch has. So typically you would combine Elasticsearch with Neo4j and have an awesome tool together to get the IDs from Elasticsearch and then the data from Neo4j.